Okay. I think it might be OBS actually. No, no. It's... Oh no, dude. Press F key. Yes. Epic. Up. Here we are. Hello there. We need to spawn our character, right? So like player start, right? Cause oops. Like that. There we go. Okay. There we go. We can zoom out a bit more, you know? So like this one with 2000? Let's test it. Oh, 1400, let's say. Let's do it like that. Oops. Eh. Hang on. Give it 800. Alright, let's go. No, not you. You.
But this removes all depth from our scene and creates a more pure 2D look. The orthographic camera actually used to be quite buggy and it wasn't recommended. However, it has seen many updates with Unreal Engine 5.3 and will hopefully continue to do so.
Do collision test.
Since off the camera, we cannot use the target arm length on the
What's
screen.
7?
Instead, on the camera, we can now change the ortho width. The wider this is, the further away the camera will appear. Let's set this to 700. And you can now see that the camera appears further away. Lastly, on the spring arm, we want to look for do collision test and deactivate this. Wasn't recommended. However, it has seen many updates with Unreal Engine 5.3 and will hopefully continue to do so. Now to change the distance of the camera, we cannot use the target arm length on the spring arm anymore. Instead, on the camera, we can now change the ortho width. The wider this is, the further away the camera will appear. Let's set this to 700. And you can now see that the camera appears further away. Lastly, on the spring arm, we want to look for do collision test and deactivate this.
In the camera. This one. Oh, in the spring arm. Wait, where?
The camera, we can now change the ortho width. The wider this is, the further away the camera will appear. Let's set this to 700. And you can now see that the camera appears further away. Lastly, on the spring arm, we want to look for do collision test and deactivate this.
In the spring arm. Okay.
If this is active and something is between the camera and the player character, it will forcefully zoom in. It might be a bit hard to wrap your head around at first, but it has a lot of great built-in functionality and will save you a lot of time in the end. Let's open up the content drawer and go into the content folder. Right-click and create a new folder called input. Open this up, right.
Oh my gosh. Yeah. Okay.
Click again and create a new folder
Content.
called actions. Head around at first, but it has a lot of great built-in functionality and will
Oh
save you a lot
boy.
of time in the end. Let's open up the content drawer and go into the content folder. Right-click and create a new folder called input. Open this up, right-click again and create a new folder called actions. The input system basically consists of input actions, which are certain actions you want the character to execute, such as move, jump, attack, and so on, and an input mapping context that binds these actions to a certain button and can also apply modifiers. Let's first go into the actions folder, right-click, input, and create our first input action. I'll call this IA_jump. When we double-click this, we can see a bunch of options, but the only one we really care about is the value type.
What?
This is set to digital bool, which is correct for an action like jumping. This means that the input for this action can either be active or inactive, and that is the case for a regular button. Create another input action called IA_move. Open this up, and here we actually want to change the value type. The move action can be executed with a left or right button on the keyboard, but in many cases we'll also add controller support for the analog stick later on. This means it's not just an on or off value, but it could be a value between -1 for left, 0 for neutral, and 1 for right. Since we only want to support left and right, we want to use the value type of axis 1D float, which gives us a range from -1 to 1 on a single axis. Now that we have both of our actions set up, we want to open this up, and here we actually want to change the value type.
Okay.
The move action can be executed with a left or right button on the keyboard, but in many cases we'll also add controller support for the analog stick later on. This means it's not just an on or off value, but it could be a value between -1 for left, 0 for neutral, and 1 for right. Since we only want to
Axis
use left and
float.
right, we want to use the value type of axis 1D float, which gives us a range from -1 to 1 on a single axis. Now that we have both of our actions set up, we want to go back to the input folder. Right-click, go to input, and create an input mapping context. I'll call it IMC_platforming. Double-click to open it up. In here, we now have to register the jump
Oh my gosh.
and create an input mapping context. I'll call it IMC
Input mapping.
underscore platforming. Double-click to open it up. In here, we now have to register the jump and move actions we created to bind them to a button. Where it says,
Oh no, we didn't do the packaging. Wait, never mind.
click on the plus icon, and then on the caret to expand the menu. Click where it says none and select IA jump. Now again, expand the menu, and here we can set up which button we want to use for jumping. Plus again, and add a mapping for IA move. Here things get a little bit more complicated. First, we want to assign the D key on the keyboard for right movement. And then we want to create another binding. And then for the other binding, we want to set the A key for walking left. Now both of these buttons do the same thing though, and we need to differentiate between them for walking left and right. Since we selected a 1D axis float here, we need to flip around the input for left and the A key. So here we can go to modifiers and add the negate modifier. And then for the other binding, we want to set the A key for walking left. Now both of these buttons do the same thing though, and we need to differentiate between them for walking left and right. Since we selected a 1D axis float here, we need to flip around the input for left and the A key. So here we can go to modifiers and add the negate modifier. By default, in axis 1, you will point to the right, so for D we get the value of 1, but if we use the negate modifier for the A key, we'll get the value of -1 instead, which is what we want. But again, if we press play now, nothing really changed. We still need to tell the character to use the input mapping context and then also what code to execute when we trigger the IA jump or IA move. Open up the BP player and go to the event graph. We need to activate the input mapping context on
BP player.
begin play. Right click and get control.
Yeah, controller.
Drag off from the return value and cast to player controller. Connect the line to begin play. From the player controller, drag off and look for subsystem and get the enhanced input local player subsystem.
What?
Drag off from the return value and cast to player controller.
Oh, cast to play controller. My gosh, dude.
Connect the line to begin play. From the player controller, drag off and look for subsystem and get the enhanced input local player subsystem. Here, drag off and look for add mapping context. Connect the line to begin play.
Yeah.
From the player controller, drag off and look for subsystem and get the enhanced input local player subsystem.
Okay.
Here, drag off and look for add mapping context.
Okay.
And then connect the lines. Very
What?
important, on the add mapping context, we need to assign our IMC platforming or this entire thing won't work. Now that this is set up, we can just move to the side a bit, right click and look for IA jump.
Okay, we don't need that.
We can expand this and drag off from start. And here we can drag off from triggered and print string. And just drag in the access value. Now go back and start the game. And very important, we need to click into the viewport with the mouse one time to start. And here we can drag off from triggered and print string. And just drag in the access value. Now go back and start the game. And very important, we need to click into the viewport with the mouse one time to start controlling the game. And now if we press space, you can see that it says jump. When holding A, it says -1 for left, and when holding D, it says 1 for right. Now that this is working, we can put in the actual code to make it jump and walk. And with Unreal Engine, this is rather simple. For the jump, just delete the print string, drag off from started, and look for the jump function. Then drag off from completed and look for stop.
Whoa.
If this is working, we want to put in the actual code to make the character jump and walk. And with Unreal Engine, this is rather simple. D, it says 1 for right. Now that this is working.
Oh no. Oh no. What did we do wrong? No. Damn it, bro. What happened?
Possessing the character and have the camera set up, we need to set up the input bindings and allow the character to move and to jump.
Yes.
5.1, the new enhanced input action system has become the default, and we'll be using that for this tutorial. It might be a bit hard to wrap your head around at first, but it has a lot of great built-in functionality, and we'll see.
Oh wait, a different color, aren't they?
Now that we are possessing the character and have the move, jump, attack, a 1D axis, go to the event graph. From the player controller drag context, we need to assign our IMC. Go for the down and then just look for IA move. And here we can drag off from triggered and print string. And just drag
Yes.
in the access value.
Why is your green? Mine says it's a Boolean.
And here we can drag off from triggered and print string. And just drag in the access value. And here we can drag off from triggered and print string.
Yes.
And just
damn it, dude, it's literally 1 second.
And just drag in the access.
Bruh.
And here we can drag off from triggered and print string. And just drag in the access.
Dude, stop it.
And here we can drag off from triggered. and print string.
Okay.
And just
Yeah.
drag
It's a float. Double precision float. Why? What did we do wrong?
on. The new enhanced input action system has become the default, and we'll be using that for this tutorial.
Hmm.
It will wrap your head around at first, but it has a lot of great built-in context that binds these actions to a certain button and can also apply modifiers. Let's first go into the actions folder, right-click,
Mm-hmm.
input,
Hmm. Okay. So which one is the clip that? Edit clip, right? Message stream. Clip that stream. Stop redaction. Hmm. At the stream marker, that's the one, bro. Thank you. Okay. Awesome. All right.
and create a first input action. I'll call this IA_jump. When we double-click this, we can see a bunch of options, but the only one we
Damn.
care about is the value type. Currently, this is set to digital dual, which is correct for an action like jumping.
And that's the I jump actions. No, but that's jump.
This means that the input for this action can either be active or inactive, and that is the case for a regular button.
Mm-hmm.
Create another input action called IA_move. Open this up, and here we actually want to change the value type. The move action can be executed with a left or right button on the keyboard, but in many cases we also have controller support for the analog stick later on. This means it's not just an on or off value, but it could be a value between -1 for left, 0 for neutral, and 1 for right. Since we only want to support left and right, we want to use the value type of axis 1D float, which gives us a range from -1 to 1 on a single axis. Now that we have both of our actions set up, we want to go back to the input folder. Right-click, go to input, and create an input mapping context. I'll call it IMC_platforming.
Wait.
Double-click to open it up. In here, we now have to register the jump and move actions we created to bind them to a button. Where it says mappings, click on the plus icon,
Oh my
and then on the context
gosh.
menu. Click where it says none and select IA jump.
Do you change the other one?
It consists of input actions which are modified. This means that the input for this action can either be active or inactive, and that is the case for a regular button.
Mm-hmm.
Create another input action called IA_move.
Mm-hmm.
Open this up, and here we actually want to change the value type. The move action can be executed with a left or right button on the keyboard, but in many cases we also have controller support for the analog stick later on. Use the value type of axis 1,
Mm-hmm.
jump, and move actions we created to bind. I'll just use the space.
Mm-hmm.
We want to create another binding. And then for the other binding, we want to set the A key for what on the input for left, and if we use the negate mod, also what code to execute when we trigger the IA jump or IA move. Open up the BP player and go to the event graph. We need to activate the input mapping context on begin play.
Okay.
Right-click and get controller. Jump, just to demonstrate how this works. Go further down and then just look for IA move.
There we go.
And here you can drag off and triggered and print.
There we go. There we go. There we
Now go
go.
back and start the game. And very important, we need to click into the viewport with the mouse one time to start
Oh,
And
finally.
now you can see that it says jump.
We
When
good.
holding
We
A, it
good.
says
We
one for
good.
left, and when holding D, it says 1 for right. Now that this is work, go from started and look for the jump function. Takes to make the character jump when we string here next to the IA move, drag off from triggered and look for add movement input.
Mm-hmm.
Here we connect the axis value to the scale value. And we need to set the world direction. If we go back to the map and select the player start, we can see that the red arrow is the direction we want to go. If we drag around the red arrow, we can see that the X value is updated here on the X and leave Y and Z at 0. Now when we start the game and click into the viewport, we can walk left and right, and all this might seem
Mhm.
to you, but the jump function and the add movement input function are nodes that Unreal Engine has prepared for us. These are things that are commonly used in all types of games, so there's no need for us to reinvent the wheel. Of course, right now there are still a couple of issues with our character, which we'll solve step by step. But this was the general way you go about setting up inputs and adding new actions to a pawn.
Mm-hmm.
Let's now make sure that we transition properly between the idle, walk, and jump animation, since this will
Yes.
make the game feel much more complete. Open up the BP_player and look for the tick
BB_player.
event. The tick event will be fired off
BB_player. BB_player. Oh, you already need it.
on every every single frame and is the best way to keep something like an animation state up to date. First, we just want to switch between the idle and walking state, and to determine if we need to switch or not, we only need to know if the character is currently moving or stationary. To do that, we can just right-click and get velocity. And then look for vector length. We don't really care about the direction in this case, and vector length will simply give us a value of 0 if we're not moving, or a positive value if we are moving. So here we can simply check for greater than 0. Then put a branch here, which basically is an if-else statement if you're familiar with other programming languages. Then we can drag out a reference to sprite, which is actually the flipbook component. Then put a branch here, which basically is an if-else statement if you're familiar with other programming languages. Then we can drag out a reference to sprite, which is actually the flipbook component. And here we can then call set flipbook and set the new flipbook to fb_player_run. Then connect this node to the true output of the branch. You can also double-click these lines to create reroute. Keep something like an animation state up to date. First, we just want to switch between the idle and walking state, and to determine if we need to switch or not, we only need to know if the character is currently moving or stationary. To do that, we can just right-click and get velocity. And then look for vector length. We don't really care about the direction in this case, and vector length will simply give us a value of 0 if we're not moving, or a positive value if we are moving. So here we can simply check for greater than 0. Then put a branch here, which basically is an if-else statement if you're familiar with other programming languages. Then we can drag out a reference to sprite, which is actually the flipbook component.
Oh, okay. Yeah. There we go. This is the sprite. Okay.
And here we can then call set flipbook and set the new flipbook to fb_player_run. Then connect this node to the true output of the branch. You can also double-click these lines to create reroute nodes to organize the blueprint a little bit. Then we can just select all of this, Control-C to copy, and then Control-V to paste, and connect it to the false case. Here for the new flipbook, we want to select the fb_player_idle. And now we can just go back to the map and press play to check this out. We are now correctly switching between the walk and idle animation if we are moving. Next up, we want to put in the jump, rise, and fall animation as well. First, we want to clean this up a bit, and we can select all of these nodes so we use for switching between the run and the idle. If you can't select all of them at once, you can hold Shift or Control to get them in multiple goes. Then right-click one of them and collapse to function. Call this update animation and move it over. Now double-click to open it up. This still does exactly the same thing, but it's encapsulated nicely and a lot easier to maintain. Now at the place before we decide between the idle and run, and collapse to function.
Whoa.
Jump, rise, and fall animation as well. First, we want to clean this up a bit, and we can select all of these nodes so we use for switching between the run and the idle. If you can't select all of them at once, you can hold Shift or Control to get them in multiple goes. Then right-click one of them and collapse to function. Call this update animation. And right-click one of them.
Right.
And collapse to function. Call
Functions.
this update animation.
I am so confused.
Then right-click one of them and collapse to function.
Oh, collapse the function. Damn you. This is so tiny. Oh, there we go. Blah.
Call this update animation and move it over. Now double-click to open it up. This still does exactly the same thing, but it's encapsulated nicely and a lot easier to maintain. Now at the place before we decide between the island.
What do you do?
Now double-click to open it up. This still does exactly the same thing, but it's encapsulated nicely and a lot easier to maintain. Now at the place before we decide between the island run, we want to open up some space. Here we now look for is moving on ground, which is a method available on the character movement component.
But this is for the
Here
jump.
we can add another branch. Connect it, and then also connect the true output to what we were doing before. Because if we are moving on the ground, we need to decide between the walking and idle like we have been doing before. Now for the false case, we want another branch.
Idle?
And here we want to check if the character is currently going upwards or downwards. For this, we can just
Down.
type velocity. Right-click the return value and split struct pin. Now we need to character movement component. And here we can add another branch. Connect it, and then also connect the true output to what we were doing before. Because if we are moving on the ground, we need to decide between count, which is a method available on the character movement component. And here we can add another branch. Connect it, and then also connect the true output.
Goodness me, I don't remember doing this. Damn it. Damn it. Okay.
We were doing before. Because if we are moving on the ground, we need to decide between walking and idle like we have been doing before.
Yes.
Now for the false case, we want another branch. And here we want to check if our character is currently going upwards or downwards. For this, we can just get the velocity. Right-click the return value and split struct pin. Now we need to know if we want to use the X, Y, or Z. Again,
Right.
if we go to the map and click on the player start, we know that the blue arrow is upward. And look, the FB player jump is to not check for smaller than 0, but check for something around -100. That way we... And in the false case, play the FB player jump rise. And now you can see that we can properly switch between jump rise and the falling animation. A nice little trick to make the transition a little bit smoother is to not check for smaller than 0, but check for something around -100. That way we don't switch animations directly at the apex of the jump, but after descending a little bit. This just makes it feel a bit more natural in my opinion. And
Yeah, we don't need
animation
that.
switching for your paper 2D flipbooks. For simple things like we did now, this method works just fine. However, once you make more complicated games with a lot more animations, this can be a bit hard to manage. For that reason, somebody made a free plugin called PaperZD, which adds support for animation graphs that make handling animation states much simpler. This is definitely something that will make your life a lot easier when making 2D games with Unreal Engine. I actually made a full 12-hour course about 2D games.
And then right now we're inside a
Started
function.
slowly by creating a simple quick draw mini game, then move on to creating a classic arcade masher
Yeah,
game,
yeah,
and the last
okay.
projects will make use of the free PaperZD plugin, and we'll go into detail on how you can set it up and get the most out of it when making more complex games. We'll use this to create a platformer game with enemy AI and gimmicks, and lastly to also create an action platformer in a 2D hybrid style that includes melee combat and some Metroidvania elements. So if you're interested in mastering Unreal Engine 2D, check out the discount link in the description. The next thing we want to do is make our character turn left and right when walking, because now we're always just pointing to the right. This is actually
Yes.
quite easy to do. Back in the VP_player, we want to go back to the event graph and look for our IA move event. After the add movement input, we want to right click and get controller. Then drag off here and set control rotation. We can drag off from new rotation and look for select. Use the utilities select here. This acts very similarly to a branch, but in situations like this, it can be a bit easier to use. This will now basically just let us pick between two options for setting the character's rotation. This is actually quite easy to do. Back in the VP_player, we want to go back to the event graph and look for our IA move event.
Mm-hmm.
After the add movement input, we want to right click and get controller.
Yes.
Then drag off here and set control rotation. We can drag off from new rotation and look for select. Use the utilities select here. This acts very similarly to a branch, but in situations like this, it can be a bit easier to use.
Mm-hmm.
This will now basically just let us pick between two options for setting the character's rotation. And how do we decide this? Well, the action value will be something negative for left and something positive for right. So we can just drag off and check for greater than 0 and plug this into the index. Let's start with the true case. Drag off here and look for make rotator and select the one all the way at the bottom. Let's start with the true case. Drag off here and look for make rotator and select the one all the way at the bottom. If this is true, we want to point right, so for this we can just leave everything at 0. For the false case, again, make rotator. When moving left, we want to turn the character by 180 degrees on the z-axis, so here we can just put in 180. Now if we start the game and walk right, everything is fine, but if we walk left, you can suddenly not see the character anymore.
Mm-hmm.
This is actually a sign that the turning is working correctly. You can hit Shift and F1 to get the mouse pointer back and then click on eject to see what's going on. We can see that the character is now corrected
Yes.
file map. Let's stop the game and fix this really quickly. On the BP player, go to the spring arm, and on the right side, click on rotation. We want to set this to world, which will then show up as absolute rotation. And now if we try this out, you can see that we are properly turning left and right, and the camera is ignoring the rotation of our character.
Okay.
But our character still feels very floaty and not fun to control. This is because the default settings on the character movement component are not that great. Open up the BP_player and select the character movement component. Here just look for gravity and set it to something like 3.0. Now if we play the game, you can see that the character falls much faster, but we also need to change the jump power to accommodate for that. Back on the character air control to something like 0.7 to some value.
Oh wait, that's it.
One more problem we have is that if we try to walk off the ledge, instead
Right.
of falling instantly, we just awkwardly walk downward slowly.
So
This happens because of
somewhere
the capsule
collision.
component in the BP player, and capsules are really nice
Oh,
if you have
capsule.
stairs and
Yeah.
slopes.
Capsule.
But for things like these, they can lead to problems.
Don't tell me, don't tell me, don't tell me. It was only with collision. Generate collision. Yo. Collision simulated. Yeah. Totally
There's
done.
a simple setting for this on the character movement component. Just look for floor and activate use flat base for floor checks. And now we for
Fuck it. Add a simulation generated sheet events. Okay. Floor. It was in floor. Damn it. What is going on? Oh, it wasn't in capsule?
checks.
Oh, it's a current moment. Damn.
Activate use flat base for floor checks. And now we fall instantly, like it is the case with most 2D games. One last setting we want to adjust on the character movement component is the movement constraint. Even if we make a 2D game and only have an input set up for left and right, it could still happen through physics or forces that we are being pushed into the foreground or background. To prevent this, we can go to the character movement component in the BP player and look for constraint. Activate, just look for floor,
Okay.
and activate use flat base for floor checks.
Mm-hmm.
And now we fall instantly, like it is the case with most 2D games.
Awesome.
One last setting we want to adjust on the character movement component is the movement constraint. Even if we make a 2D game and only have an input set up for left and right, it could still happen through physics or forces that we are
Right,
being pushed into the
yeah.
foreground or background. To prevent this, we can go to the character movement component in the BP player and look for constraint. Activate constraint to plane. And in the plane constraint normal, we need to set the direction in which we want to constrain the movement. Again, if we look at the player start, we can see that the green axis is the one which we want to prevent movement in. And this is the y-axis. So on the y-axis, we just set the plane constraint normal to 1.0 to activate it. And now we can be absolutely sure that the character will never leave the original lane. And this is all we have to do to set up the base for a 2D game in Unreal Engine. This might seem like a lot,
Okay.
and it is a lot to remember, but once you've done this a couple of times, it feels like second nature. However, I actually made a free template that is open source that already has all of this set up. You can easily add this to Unreal Engine and create all of your new 2D projects from it, so you don't have to go through all of these steps every single time you want to make a 2D game. But it's very important that you followed along with this tutorial and did everything at least once, so you can understand how all of these different things work and expand upon them. And as a patron, you can also get 2 more advanced templates that use Paper Z animation.
Okay. Now. We should finish it off. Engine 5. Oh boy, oh boy, oh boy.
Just covering UI, okay? Okay, if you're new here, my name's Taken Grace. I do Unreal Engine tutorials.
Good hard blueprint
We're going to
class.
open up our content drawer by hitting Control Space.
Mm-hmm.
We're going to make a new folder. We're going to call it UI.
Yes.
Everything to do with your UI will go in this folder. That'll be your HUD class. That'll be all of your assets and all of the widgets that we're going to make as well.
Mm-hmm.
Okay, so we're going to right click and we're going to add a new blueprint class. We're going to go down here to all classes and search for HUD. Okay, we're going to select all classes and search.
Whether we went the UI. Okay.
We're going to select HUD and we're going to select and start that here. And we'll just call it HUD class. Okay, so
Right.
HUD. Yes, we're going to go
Oh,
down
blueprint
here to
class.
all
Okay.
classes and search for HUD. Okay, we're going to select HUD and we're going to select and start that here. And we'll just call it HUD class. Okay, so this is where we're going to create all of the widgets, add them to viewport, and manage all of the events in our game that have anything to do with our HUD class, okay? This is a really powerful way to control all of the user interface stuff in your game. All of the widgets will be inside this class, so we'll just open it up here super quick. Okay, so it's just exactly like another blueprint, except the parent class is the HUD class, okay? You can create variables, we can create all of our widgets in here, and then all of our widgets can talk to each other in this blueprint, and we don't have to cast or create other ways to talk to the other widgets outside of this. And then if we, in any other blueprint, if we need to get our class, we just need to get actor of class, and select the HUD class. Okay, now we have a reference to our HUD, and we can run events based off of that. Okay, so it's much better than casting to your player or getting a reference to your player in any other way, and accessing the HUD if that's where you've created your main master widget HUD there. Okay, one final thing we need to do here before we get started is we need to open up our content drawer again. We need to go to the third person folder and go to blueprints, and we need to find the third person game mode. Okay, we're gonna open that up. Okay, this defines all of the default things in our game. So our player, which is our default pawn class, and our default player controller class, and also our default HUD class. So right now this HUD is on the C++ default that comes with the template. We need to select our HUD class that we just made. So now that our default HUD that the game will be referencing is the HUD class, okay, that we made. Our default pawn class. class, and our default player controller class, and also our default HUD class. So right now this HUD is on the C++ default that comes with the template. We need to select our HUD class that we just made. So now that our default HUD that the game will be referencing is the HUD class, okay, that we made. Okay, so we're gonna hit compile, and we're gonna go and now make our first widget here. So we're gonna open our content drawer, go to our UI folder.
Wait, what?
Things in our game, so our player, which is our default pawn class, and our default player controller class, and also our default HUD class. So right now this HUD is on the C++ default that comes with the template. We need to select our HUD class that we just made. So now that our default HUD that the game will be referencing is the HUD class, okay, that we made. Okay, so we're gonna hit compile, and we're gonna go and now make.
What is that
so
compile thing?
UI folder.
What?
Okay, we'll put all these in a separate folder, so we'll make a new folder and call it widgets.
Uh.
Open that up. Okay, so to make a widget, we need to go to user interface and go to widget blueprint. Okay, we'll bring this up, and we're just gonna select user widget, and we'll name it widget blueprint.
User interface. Widget blueprint. User widget.
UB underscore level up. Okay, we're only gonna make this widget today because I'm gonna show you guys all the things that happen in here, and there's a good chunk of stuff in here that we can do that will give you a really good taste of what it's like to make a widget and give you enough knowledge to go on your own afterwards and make some.
What do you do? WB.
Okay, so let's open this up.
Why WB? Oh my gosh.
And there's a good chunk of stuff in here that we can do that will we need to go to user interface and go to widget blueprint. Okay, we'll bring this up, and we're just gonna select user widget, and we'll name it widget blueprint WB underscore level up. Okay, we're only gonna make this widget today because I'm gonna show you guys all the things that happen in here, and there's a good chunk of stuff in here that we can do that will give you a really good taste of what it's like to make a widget and give you enough knowledge to go on your own afterwards and make some. Okay, so let's open this up. Okay, I will start by going through the widget editor here just to give you guys a bit of an idea of what's in here. If you guys don't need this part of the tutorial, you can skip ahead. I've put lots of chapters down below so you guys can keep up with what we're doing, and you can skip ahead to that where we're actually gonna start building the widget. Okay, but for all of you guys that are looking to level it up here, all right, so our attention up here. This is the palette. This is where all the things are that can go into a widget. Okay, most commonly you're just gonna search up here for what you need. Okay, but if you wanted to scroll through here and find all the stuff that you want to do, all right, and then down here is our hierarchy. So our hierarchy will be basically our layers of the widget. So we're gonna build a bunch of stuff down here, and it goes from top to bottom is actually reverse. So the thing that's on the top, that's actually the bottom layer, and then the thing that's on the bottom is the top layer. So it's a bit reverse. Okay. Details over here will populate once we actually get going on stuff, and I can show you some stuff over there. Okay. Up here we have fill screen, custom on screen, desired, and desired on screen. Okay. So we're gonna stay on full screen, but what these do is if you are working on a widget that isn't necessarily going to be either taking up the entire screen or on your screen while you're playing or anything like that. So a really good example is a inventory slot. So that is not going to be taking up your entire screen. That's going to be a very small slot that you're going to be using inside usually a hotbar or an inventory page or something like that. Okay. So you're going to select desired on screen, and then that's going to show you what the widget's going to look like as on its own basically. Okay, but right now we're going to be making a level up screen, so that's going to take up our whole screen, so we're going to stay on fill screen. Okay, so if anything looks super weird when you're making it, just try to cycle through these and see if you can get it to look desired on screen usually fixes that. Okay, screen size. So if you know you're making a game for a phone, for a laptop, or whatever, you can select the specific size right now. So I think right now we're on 1280 by 720. So now we can select the screen size of, for example, 27-inch monitor, which is what I'm rocking here. So 2560 by 1440, which is the monitor I'm using. Okay, let's get started here. So let's go up to the search palette and let's type in a canvas panel. Okay, so CAN's enough to get that.
Oh boy.
Drag the canvas panel right here on top of level up. Okay. What a canvas panel is, a canvas panel will add anchor points to your widget so that you can anchor certain things to your screen, okay? You don't always need a canvas panel, so for the example I gave with the inventory slot, you would not use. We're gonna drag the canvas panel right here on top of level up, okay? What a canvas panel is, a canvas panel will add anchor points to your widget so that you can anchor certain things to your screen, okay? You don't always need a canvas panel, so for the example I gave with the inventory slot, you would not use a canvas panel with that because you're not anchoring it to screen anymore. You're gonna be adding it to probably some sort of wrap box or something like that. So, but for this canvas panel now, we can basically control the layout of our widget, okay? Okay, so now we'll just go ahead and add another thing here. So we're gonna type in image, and we're gonna add this image to our canvas panel. Okay, so let's name this widget by pushing F2, or this widget, pardon me, the image, and we'll call it BG to blur, because we're gonna blur our background. Okay, all right, so now that we have added this image, you can see now that we have this little flower here. Okay, this flower is telling you where the anchor point currently sits with this image here. Okay, so if I zoom in here, you can see that it's in the top right, or probably the top left corner of this image. Okay, so if we come up here to the details, this is slot canvas panel, meaning that the slot for this image is attached to the canvas panel. Okay. So with that in mind, we can come to anchors, and now we can select any of the anchor points here on this canvas panel that we can attach this image to, okay? You can see down here it says hold shift to update the alignment to match and hold control to update the position to match, okay? So let's just select this top one here, and you can see by just selecting it, it's moved the flower over here to where we've selected that anchor point, but it has not moved our image over there. And you can see that it's offset by 960 degrees on the X here, and that's just because we clicked on it, and it wants to maintain that particular position that we had before, okay? So we're gonna click on this, and we're gonna hold down control, and
you know, I am really hungry. Let's put this one up by YouTube. Boy, searching for create Unreal Engine main menu.